Okay, good afternoon, everybody. My name is Marlene Luckner. I'm the marketing manager from Arcam Systemautomation, and I wish you a warm welcome to our seminar about Simcenter, simulation and testing. As an innovative company, Arcam is supporting its customers since 1994, primarily in the areas of product development and manufacturing. Arcam offers integrated solutions that cover all phases of the product lifecycle. As top partner with the Smart Expert status from Siemens Digital Industries, we have round about 40 employees at 3 locations in Austria. And do not only offer you the extensive portfolio for software and hardware from Siemens, on top we propose services from professionals who support you or can do the simulation and testing for you. Arcam Systemautomation and its subsidiary Arcam Engineering are the perfect combination between software, hardware and service provider. Today, Florian Schüssler from Arcam Engineering will give you a short overview about Simcenter 3D and the chances for your business. A warm welcome to Florian Schüssler, and please mute your microphones and post questions in the chat. We will answer your questions after the presentation. This presentation will be recorded.
So what are the challenges in simulation today, and what's the topic we are talking about? So it's all about answers to our questions we have to our product, to our design, and so on. And this will happen, or this is the case today. This is digitally. So, for example, which questions will it break? How long will it last? Is it noisy? What's the temperature in? Do I have the right size for the load? And so on. So this is today everything developed and answered with simulation, and today in special with Simcenter 3D. So what's the benefit for you if you use simulation? One benefit is the reduces need for physical prototypes. So mostly if you do simulation in advance, the first or the second prototype will meet all your requirements. This in the next step leads to reduced costs, and in some it speeds the development process of the product development. And some numbers we see today, 32. I think you will or you have experienced that also on your own. 42% of the projects are still late. It's difficult to collaborate with other departments, and 80% of the questionnaires answered that simulation is still too slow. And these challenges is the aim to overcome. And what's the reason for slow CAE process? Normally you have to invest quite a lot of time to repair and to edit the geometry, do some defeaturing, build your finite elements and the meshing process, and afterwards the solutions with the solvers and the post-processing. And in some this process could be quite slow, and this leads to this slide that simulation today is still a bottleneck. So you have, for example, the designer with 2-3 different CAD designs, And if you are at the stage of the beginning of the fourth designs, you maybe receive the result from the first simulation. So at that stage, the simulation results are not accurate anymore because there are 2 or more different design stages in between. And this is quite a challenge also. That simulation is always a little bit behind the stage in the product development. So you also have the different design phases or process phases. So you have the concept, the designing, and the validation phase. And simulation should be, or at today is in every different product phase part of the development. And we will soon look into Simcenter 3D in detail, but just as you maybe know, simulation today, it is quite domain separated. So it could be, or if you simulate already, you have a structures department, and you have another one who is doing thermal flow, for example, the classical CFD, and someone else is doing some multi-body dynamics, classical emotion, and yeah, someone is doing durability, for example. And sometimes these are also different programs. And then it's very challenging to unique all those single domains. If you want to have a single model which could or which can simulate all the multiphysics together. And this is the collaboration among those domains is the power and the USP of Simcenter 3D. So we will start with looking into different areas, what's possible there. Afterwards, we shape out a little bit the characteristics of meshing, model building, and so on. Yeah, this is the plan for the next minutes. So Simcenter 3D is all based on the engineering desktop. This is the heart of Simcenter. And from this engineering desktop, you can address different solvers in the different domains, for example, CFD and the classical structural analysis. And if you have generated, for example, a gearbox model, FE model with your mesh within the structures, you can also reuse the mesh in your thermal flow analysis, for example, for the conjugate heat transfer to the surroundings or whatever. So it all shares a common database. And this is the most comprehensive, fully integrated CAE solution. That's the slogan for that. And I have started to explain. So one basic characteristic is the common engineering desktop, which integrates all the multiple disciplines. Every different field, simulation field, has also world-class solvers which are integrated, and not you are not forced to use, for example, the Nastran solver. You can also combine the engineering desktop and your simulation fields with third-party products. Example given Abacus or LSDyna and so on. So this is also possible. one of the good things is there are integrated applications. We will take a look then afterwards into to achieve agile simulation processes. And if you want to combine it with the process and data management, that's also possible to connect between different departments and connecting simulations to development. And you can go into the data management, for example, and you have the documentation, which model was analysis or which from which time and from which data was your analysis performed and so on, which is called Teamcenter for simulation, is the product for the process and data management. So the questions we opened in the beginning, these are the answers. So Simcenter helps you to model the complexity. It helps you to speed up your development or your simulation process. It's possible to explore the possibilities, and you can or you are able to stay integrated to the process and data management. So you see it in this picture. Simulation today often is not connected, so you do not have a common model. You have parts of the model which are assessed and simulated, but the gold standard would be to have a single model from which, with a common database, from where on you can go into your different physical disciplines. And this is where we take some looks into. We begin with Simcenter structures. The overall explanation for that is it is linear and nonlinear analysis to ensure structural integrity. So the overall term is the structural integrity which you want to assess, and what can you do within the structures discipline or the structure solver. Normal linear analysis, but also multi-step nonlinear. Just to talk a little bit about solvers and analysis techniques. The classic or the standard solver for Simcenter structures is the Nastran solver. Nastran is the word for NASA structural analysis, which was developed I think in the Gemini project in the USA, which then afterwards leads to the moon flights with the Apollo mission. So it's quite a very long validated solver code. And the classical solution, for example, it's everything described in solution numbers, is the 101 for the linear solution. And if you want to go into nonlinearity, since 2016, the SAMCEF solvers are available within the Simcenter structures module, which are state-of-the-art and very modern and fast nonlinear solvers. So what is meant with multi-step nonlinear, you can either simulate your nonlinear material, for example, plasticity, creeping effects, and so on, but also large deformations, large strains. And you can split that further up into the time nonlinearity, so you can assess large sliding on contacts, and so on. So these are the two stress solutions, linear and nonlinear. Then if we go a little bit more into the dynamic behavior, we are able to do modal analysis to create and to see the eigenvalues of your structure. You can also assess buckling, for example, large and thin structures where the stress might not be that high, but buckling could lead to a failure. And last but not least, there is also an optimization solution, either for entries in the property like density, plate thickness, but also for topology. This is the Nastran topology optimization, where you can simulate your optimal or optimized structure, for example, 3D prototyping or rapid prototyping. Yeah, there are also always some statements in that from research and development department from a Chinese machine tool company. The saying is they reduced simulation time for 50% with also quite accurate results. So yeah. Next part, I have picked out just some parts due to the limited time we have. So we will go over structures, dynamics, thermal flow, and motion, because those are the most interesting. If you have some different needs or want to see some other simulation fields, please just tell me, and we can look also in the different fields. Dynamic, the overall explanation is predict vibrations and responses and correlate them with test measurements. So within the dynamics module, it's all connected to vibration, noise, and maybe a failure due to vibration. So what do we see here? The dynamic solutions, the transient response, modal response, and so on. They are also connected to the Nastran solver, and they have their own solution numbers. And the test analysis correlation, which we can see here, is connected to the products, measurement products, or also software products from Testcenter and LMS software. So it's quite, because it's a complete integrated process. So if you have available measurement data, it's quite easy to validate your simulation in topic of dynamic behavior within Simcenter 3D. So what are some classical fields in here? It's the NVH, the response dynamics. For example, you have a force with a certain frequency applied, and you have your damping in your model. You can assess and simulate what would be the maximum deformation, for example, out of those loads. Also, some companies are very interested in the rotor dynamics. and the load identification. So I think the biggest customer of Simcenter in this area is Mercedes-Benz. They are doing their simulations with Simcenter Nastran in the different fields. We are also providing engineering service to a subsidiary of Mercedes in Austria, and we simulate there the exhaust system, and they have a very strict way to do the simulations, so everything is defined. Example given the mesh quality, the mesh size, how to apply the loads and so on. So this is this boundaries are given from Mercedes-Benz, and they are using for their simulation Simcenter 3D. So what are they doing? They have already achieved high standards for NVH, noise, vibration, and harshness. They have models up to 50 million degrees of freedom, so nodes in the model, which also is quite challenging for the solver itself to work with those big models. They also do the correlation to their measurement, and extend the Simcenter simulations to more use cases. So they have a 16-year partnership with Siemens Digital Industry, and here you see some models and meshes, for example, acoustics or NVH, which they are building and using. The next field is the thermal flow. It's a little bit maybe not quite identifiable at the first, because there is also a thermal flow application within Simcenter 3D. This thermal flow application is different to standalone products within the Simcenter portfolio, like Star CCM. So the thermal flow in here uses the Maya heat transfer technology solvers, which is a Canadian or North American company who developed their first thermal solver, I think, in 1994. So it's also quite a very proven product, and it's used for the Simcenter 3D thermal flow or CFD simulations. So what do you want to do with thermal flow? Understand the thermal characteristics, and maybe combine them with fluid characteristics, and then you also have a co-simulation, which is called thermal flow, and assess your model in this way. So which fields are possible to solve? The first is the conduction, very close connected with convection. Then you always have in those thermal applications some radiation due to example given infrared radiation. It is also possible to simulate phase change. This is the classic, the conjugate heat transfer. We are able within Simcenter 3D to simulate compressible and incompressible flows, two-phase flows, and non-Newton, also non-Newtonian, non-Newton, nicht Newtonsche, non-Newtonian sorry for that. Fluids, the classic example for this fluid is blood, which has a very special behavior, and you need those fluid models to get accurate results out of that. So this is everything, or all those possibilities are possible to simulate within Simcenter 3D. Here is also this is a customer from us, which I find very nice to have them in the global Siemens slide deck. They are using Simcenter 3D thermal flow in hydraulic management and oil coolers, and achieved quite and good results with this solution. You can see here also they have combined special 1D elements with a 3D fluid mesh. So you are with that model technique, you are able to reduce the number of cells quite heavily, but get the same accurate results with a thermal connection for the surrounding air, for example, or metal or whatever. Yeah, the last field I want to pick out is the motion simulation. So it is or sometimes people think of visualization in terms of motion, but motion itself is the functional behavior of assemblies and mechanisms. So you define joints, connections, speeds, for example, and assess forces, acceleration, movement, time, and so on of your assembly and mechanism. So it's really the technical description of the movement, and not just the visualization, which you could do also in your CAD, for example. And it's quite powerful. We use it in our service projects also quite often. The first is just to use rigid bodies, which is your CAD assembly, and with the density and the acceleration or speed, you create forces on joints or connections, and are able to assess those forces. But you can also combine the rigid bodies with flexible bodies, so you are able also to assess the deformation within a movement. So for example, if you stop suddenly and you have a weight attached to the front, the part itself wants to or will deform a little bit due to the still to the inertia of the weight which is attached. And if you simulate those with a rigid body, you cannot predict those deformation. So in combination with the structures mesh and the Simcenter structure solution, it's possible to integrate those flexible bodies and see the deformation in the motion process itself. It's also the Simcenter motion is also it is possible to couple it with 1D simulation. So if you have a control net or some bigger systems in the background, you can just simulate one aspect of your assembly and do the rest of the simulation in your 1D model. And then we have some special solutions in here. Example given, the tires, interference checking. There are also applications for transmissions and gears. There are flexible hoses and real-time hardware in the loop, but those are special solutions for that. So there is another statement from Faurizia. He is a functional simulation expert. They are using, for example, to assess how a defect in production will affect the mechanism itself, or is it still operating, or is there some are there some changes needed? It's just a single example out of hundreds, where motion simulation is useful. Just for the time, I think it's 45 minutes. Is that correct, or? Super. Good. So we have seen the different disciplines and the combination between each other. So now some facts or details of the program itself of Simcenter 3D. So the first, we look into the engineering desktop, and the real benefit is the time you need for building your simulation model. Example given, the meshing process, the defeaturing process, and so on. So which functionality can you use? One is the geometry editing, also the multi-cut support. So you can import data from SolidWorks, from Creo, and so on, without to do the export step of a step file or a edges file. So it's really multi-cut supported. This is quite a really good benefit. The robust mid-surfacing, if you have a lot of plates in your model, you could use this technique to reduce your model size. It's also very quick in building your fluid domain or acoustic domain if you need it. And it's very associative. If you do design updates, then you can really speed up the simulation process by the associativity to your CAD parts. But I have quite a good demonstration for that in a few slides. So this leads to a faster those functions and the way simulations with Simcenter work needs to a faster initial iteration. So you are faster in achieving the first analysis results. And if you are updating or doing iterations, the process is quite automated. So you just have to update your mesh, and the rest is done automatically, including the start of the new analysis run. So there is a rapid update for later iterations. Here's an example how to do some iterations. Maybe you want to assess what will happen if I move my geometry quite some millimeters more in the center. So this is all done by the geometry editing. And there are really uncounted ways and possibilities to create really a great mesh. Example, a seed mesh to have a structured layer on the surface and so on. And also you can connect old legacy meshes with new geometry and bring them alive back again with the morphing technology, which is also quite often used by our customers. And what's really a huge difference to other simulation programs is the assembly meshing. So you can have one colleague meshing one part, another colleague the other part, and the mesh itself could be fitted together in the same way you are used from your CAD data and your CAD assemblies. So you build it's called assembly FEM, and the assembly FEM exists out of different single FEMs where your mesh is created, and then it's just in the create the connections, for example, a glue or a connection via 1D elements. So this is really a good way to collaborate and to manage quite big FE models. And this is a good explanation how the fast process is working. So if you want to change your angle here to have just this single block here slightly angled, example for a better support in stress. The update is quite automatically, because the 2D elements get their thickness information out of the surface, and if you change the thickness of your surface, here you see the mid surface which are created, and you move back to your FEM model, you see at your first site that these thickness of the elements which are here is automatically created out of the mid surface. So in first it was just one thickness, and now every element has a different thickness, and also the moved other plate which was here is also automatically moved to the new position. So it's really if you want to perform what if analysis, that this can also be done very quickly. This is the process I described before for the assembly meshing. So you have here 3 different parts. Everything can assessed individually as a single component and fitted together afterwards to a whole global model. And as long as you have the same standards in mesh size and so on in your company, it can be done even from different people. So you can collaborate very easy in that field. And the last, also post-processing is very intuitive, not even from the Simcenter and results, but you can also post-process results from third-party solvers. if you want to still use your old solver, but getting all the benefits of the collaboration and multi disciplines, that's also possible. Large model performance is really quite good. And you can create quick templates, use the powerful XY graphing, and so on. Yeah, so it was just a short overview of Simcenter 3D. I hope you got a quick and interesting overview and some sites of what you're interested. And I will hand over to Marlene again to manage the questions, if there are questions, or if you want to see something different.